Okay, graphs of the derived function. What's derived function mean? Yeah, basically the gradient. So as we all know, the derivative of a function is just the gradient of that function at all points. Okay, so this first bit is essentially exactly the same as when we were graphing speed and acceleration, because we were just graphing the gradient of the previous graph onto a new graph. So this is basically the same thing. So I've got this function here, let's call it f of x. I'm going to go this point A and this point B. Now when you're trying to work out how to graph the derived function, you basically look for the points in the graph where you have a zero gradient, and then the points in the graph where you've got a negative gradient or a positive gradient. So if x is less than b, is the gradient positive, negative, or zero? Good, yeah, it's this part of the graph here, and that's a positive gradient, so gradient is positive. Positive. If x equals b, what's the gradient? When x equals b, you're at this point here.
Undefined.
Not undefined, no. Yeah, 0. When x is between b and a, what's our gradient?
What?
When x is between b and a, what's the gradient of the line?
Negative.
Negative, yeah. Negative. And when x equals a?
0.
Yep. And when x is greater than a? Positive. Yeah. It's that bit of the line. It's a positive line. Okay, so if you're asked to draw that in interval notation, what we can say is just this fancy bit. Basically, that's just saying when the gradient is greater than 0, so when the gradient is positive, it's between the intervals, what? We've got a positive gradient here, so when x is less than b, so if we're talking about interval notation, what are the 2 points? If x has to be less than b. Going from where to where?
Negative.
Good, someone can read off the sheet. Yeah, negative infinity up to b, but not including b. Or, what other point? We've got a positive gradient when x is greater than a. So from a up to infinity. We're just saying the same thing as we've just said, just in interval notation. Okay, when we've got the gradient, or f dash x, less than 0, that means our gradient is negative. We know that the gradient is negative between b and a, so what would be our interval notation? B comma A. Good. And when the gradient f dash x equals 0, we've got x equals b and x equals a. So how do we write that? Well, yeah, we can just write the set of b and a, or you can write a and b, doesn't matter which way they go. But that's a set, so that means the set of just a and just b, not between them, just a and just b, because we want x equals a and x equals b. Okay? So this bit here and this bit here are saying exactly the same thing, just in a different way. Interval notation and just your own freehand. Okay, so example. We've got y, x. This is the point -3 onto -1. And we've got the point -3 and 0. And we'll call this g of x. So you have to sketch the derivative function, the derived function. So derivative is just another term for gradient. So all you're doing is sketching the gradient of g of x over the same x values. So look for when you've got a 0 gradient, look for when you've got a positive gradient, look for when you've got a negative gradient. When is the gradient equal to 0? Good, at the turning point. So that's the x value -1.5. So at -1.5, you're going to have a 0 gradient. But everything on the right-hand side of the -1.5, is that a positive gradient or is it a negative gradient? Is it getting more and more positive or more and more negative? More and more positive. So it's going to go up. It's getting more and more positive. And the other side, is it getting more and more positive or more and more negative? More and more negative, so this goes down. That's it. Yep. Yep. Essentially, all you're doing is identifying the x values where there's a 0 gradient, plotting that, and then just figuring out if it's getting more positive or more negative. Yeah.
That line that you report, that just seems like it's getting more positive. Because it's a positive graph.
This one?
No, the second line that you drew on. Yeah, that one there.
That one? No, so you're doing the same x values. The y-axis is your gradient. So like at your gradient of g of x is getting more and more negative, so your y value is getting more and more negative. So the y value down here is getting more and more negative over the same x values. Yeah?
Yep. So with the quadratic graph, see how it's kind of like getting kind of slows down how positive it gets.
Mm-hmm.
You kept drawing it, would eventually flatten out to the gradient graph.
No, it'd be linear. Yeah. Because it just keeps getting more and more positive and more negative. Yeah. There's never a point where, like the other than the turning point where the gradient would be 0, and there's never a point where the gradient would be undefined. So it just keeps getting more positive or more negative.
But would it get like less positive? You know what I mean? Because if you like kept drawing the quadratic, you see how it's kind of like almost completely straight, and then it would get really, really close.
Yeah.
Just less and less.
But if you curved this in any way, what you're saying is that the gradient is essentially changing. It's going towards a different direction, and it's not, like, it just keeps getting more positive. So yeah, you keep it as a linear line. Basically, if you want to make yourself a little note, parabolas, when you draw the gradient graph, they're linear. The gradient of a parabola is always linear. The gradient of a linear line is always flat because the gradient's not changing. Okay. Now let's talk about trig ratios. So if you draw a tangent at any point on a curve, it's eventually going to, if you extend it, it's eventually going to cross the x-axis. So for example, that's probably a bad example. Let me just get rid of that. I'll do a bigger one. Okay, this is our circle graph. I want to know the gradient at this point, so I'm going to draw a tangent line at that point. So it's got to just touch that point and have the same gradient as the circle there. So it's about that. If we keep extending it, it doesn't matter where you draw your tangent line, at some point, unless of course the gradient is 0, it won't, but at some point it's going to cross the x-axis. So what we can do is actually use our knowledge of trig ratios. If we draw a triangle out of that, we've got rise over run, or if this is our angle in here, we've got opposite over adjacent. So what we actually find is that the gradient, which is rise over run or opposite over adjacent, is tan theta, where theta is the angle made with tangent line and the positive side of the x-axis. So that's why they actually call it a tangent line. It's because you can find the gradient of it using tan theta. Maybe. Right, so that's your rule up there. Gradient equals tan theta, or I think I've got it on the sheet as tan theta equals m. Yeah, positive side of the x-axis, so just here. Oh, sorry. You know what I mean. Let's not get pedantic. Okay, so good spelling. At which the tangent makes a 45-degree angle. and B is parallel to y equals negative 3x plus 5. So find the point on the line y equals x squared minus 7x plus 8, at which the tangent makes a 45-degree angle with the positive side of the x-axis, and that is parallel to y equals negative 3x plus 5.
What's the BE mean?
Positive. Just shorthand. Alright, if our tangent line makes a 45-degree angle, what is going to be the gradient? Yeah. Think about your triangles. We know this one. A 45-degree angle is a pi on 4 triangle, which is 1, 1, root 2. Tan is 1 on 1. So tan 45 degrees equals 1. So we know the gradient of the tangent line is 1. What do we also know is the gradient? So that's the D. The derivative of the function is also the gradient. So we also know that dy dx is going to equal 1. So what is dy dx?
1.
No, what is dy dx, the derivative of the function? Derive each term. Yeah, so x squared is 2x. Bring the power down, minus 1 from the power. Negative 7x is negative 7. So 2x minus 7 is 1. Equals 1.
That's it.
Yeah, because we know that tan 45 is the gradient, which is 1. We know that the derivative is also the gradient, which is 1. So we worked out the derivative. It equals the gradient, which is 1. They both equal each other. They both mean the gradient. So now you've just got to find the point on the line. So you've got to solve for x and solve for y. Yeah.
I didn't get where the triangle.
All right. 2x equals 8. X equals 4. Then what do we do to get our y value? Yeah. 4 squared minus 7 times 4 plus 8. Squish it in. Y equals negative 4. So we got the point 4, negative 4. So that's A. So that was the A. Now for B. We want to know the point at which the tan 45... Wait, no. We want to know the point at which the dy dx, which is our gradient, is equal to the gradient that's given in the linear line. What's the gradient of that linear line?
The other gradient.
No. Y equals mx plus c. Gradient is m. So we want our dy dx to equal negative 3. So you've already done dy dx. It was 2x minus 7. And we want that to equal the other gradient. So then from there, it's just rearranging. So x equals 2. Y equals 2 squared minus 7 times 2 plus 8. Did I... Oh, I think I made a mistake on the sheet. You can pick it up. I just did a positive instead of a negative. So, what do we get? Negative 10 plus 8, negative 2. So we get the point 2, negative 2.
That's it?
That is it.
Wait.
Okay, the other question, these get even harder. Right, a plane's path follows the equation. Okay, so we've got the equation 1/4 x to the 4 plus 2/3 x to the 3 for x is greater than 0. So we're only looking at the positive side of the x-axis. Okay, find the direction of motion when x equals 2. Okay, so direction of motion, what is it actually wanting? No, it's wanting a bearing actually. So we want to know the degrees bearing. So essentially what we're looking for is the angle that the tangent line makes with the x-axis. Yeah. Theta is what we're looking for because it'll give us some degrees. No.
So is it asking for, it's not asking for like true length?
No, just a degree. Yeah. Okay. So what we're looking for is actually tan theta equals gradient. Okay, to work out theta, what do we need to know? From this tan theta equals gradient, we need to know the gradient. So how do we find the gradient? The derivative, dy dx. So of the function, what's the derivative? Yes, good. Because if we bring that 4 down and multiply, we get 4/4, which is 1. Bring the 3 down and multiply, 2x squared. Good. Okay, so that is the derivative of any point on that line, but we want to know when x equals 2. So what's the derivative when x equals 2? Yeah, so you want to just sub into the derivative formula. So we get 8 plus 8, 16. So the gradient when x equals 2 is 16. So tan theta is 16. How do we find theta?
Inverse tan.
Very good. Inverse tan. That you're not expected to know off the top of your head, use calculator. Should your calculator be in degrees or radians? Good. Make sure it is in degrees. It's 86.42 degrees. So that's the direction of motion. You're going 86.42 degrees true, I guess you would say.
Isn't true using north, south, and west?
No, that's compass bearings. True is going from north clockwise around.
Wouldn't that be from the y-axis?
Yeah.
It's from the x-axis. I said 16.
Yeah, maybe you'd have to
It would be 90 minus 86. True. I don't know, maybe.
Yeah, you'd have to draw it and see where the tangent line actually is. I'm not sure. But that's essentially all it was asking for. It was theta. Okay, question B. So we're using the same plane's path as before, but find a point on the plane's path that is inclined at 45 degrees to the positive side of the x-axis. Find the point on that line that is inclined or maybe that's what the previous question was asking, is the incline, like from the ground up. Yeah, maybe like angle of elevation is maybe what I was saying. Yeah, because that's what you talk about when you're talking about planes. Go up. Yeah. Okay. On the positive side of the x-axis. Okay, if our angle of elevation, our theta, is 45 degrees, what's our gradient? Yep. You know? Tan 45 equals 1. So therefore, our derivative, dy dx, is going to equal 1. What is dy dx? We already worked it out before. We said x cubed plus 2x squared is equal to 1. Now, try it without looking at the sheet to work out what x equals. Hint, it's not easy. Division of polynomials.
Use this, what's that thing called?
Yeah.
No, it's called the special case. No,
Special case, no.
no, it's not. It's
I would say P of A.
yeah, like x minus a.
Yeah, exactly. So, first we'll change it into this form. So just take the 1 over. Right, we need to find factors of -1. When you do P of A, it equals 0. So we need a proper factor, no remainder. So what's your factors of -1? 1 and -1, right? I'll give you a hint. Test P of -1.
I'm going to say 0.
It's going to be 0, yeah. So you sub in x equals -1.
Is it x plus 1 or x minus 1?
It'd be x minus a, where a is -1, so it'd be x plus 1 is a factor. Yeah. Minus 1. That equals 0. So we know that x plus 1 is a factor. How do we factor out x plus 1? Polynomial division. Yay. Right, so we get x cubed plus 2x squared minus 1. Remember, see if you can remember how to do it. Yeah, so say, what do we times x by to get x cubed? It's x squared. Times x squared by x plus 1, we get x cubed plus x squared. Then we minus them, so that cancels out. 2x squared minus x squared is 1x squared.
There's a problem with the equation.
Bring everything down. Yeah, then what do we times x by to get x squared? It's x. So x times x plus 1 is x squared plus x. X squared minus x squared is nothing. 0 minus x is -x, and bring the minus 1 down. Yeah. Right, what do you times x by to get -x? It's -1. -1 times x plus 1 is -1. You minus those, you get 0. So this here is your other factor. Those are your two factors. So you get x plus 1, x squared plus x minus 1. We have it, that equals 0. That's from here. So that's saying the same thing, just factored. Still haven't figured out what x is though. So null factor, we know that x plus 1 equals 0. So that's x equals -1. What are we going to do for the quadratic? Yes. So I'll do it up here because we're running out of room. Negative b, which is 1, plus or minus the square root of b squared which is 1, minus 4ac, which is 1 times negative 1, so that'd make it a positive 4, over 2a, so 2 times 1, 2. Right, so x equals negative 1 plus or minus the square root of 5 on 2. So we've got this one and these two. We've got 3 solutions. But the question is asking for the positive side of the x-axis. So which one of those 3 solutions, these two or this one, it gives you a positive? Yeah. So to be x equals minus 1 plus root 5 on 2. That is your one solution. Final answer. Yay.